My dear students, in the previous video, we have started to solve the problems in integration, the two definite integrals. So in this video also, I am going to continue the problems in definite integrals. Definite integrals by using properties of definite integrals. Properties of definite integrals. Definite integrals by using properties. We are going to use definite integral properties to solve the problems in integration. So, evaluate, consider the problem. Evaluate integral 0 to pi by 2 e power x into 1 plus sin x by 1 plus cos x into dx. This is the problem. Evaluate integral 0 to pi by 2 0 to pi by 2 e power x into 1 plus sin x by 1 plus cos x dx. Evaluate the problem using the properties of definite integrals. Now, here I am rewriting this problem as 1 by integral 0 to pi by 2 1 plus sin x. I write as it is, but 1 plus cos x by using trigonometry result. You know 1 plus cos x is 2 cos square x by 2. So numerator you keep as it is 1 plus sin x. The denominator 1 plus cos x is by using trigonometry result. 1 plus cos x is 2 cos square x by 2. Now I am going to split this into two integrals, that is 0 to pi by 2. 1 by 2 cos square x, 2 cos square x by 2 plus sin x by 2 cos square x by 2 into d. I split this integral into two integrals, that is integral 0 to pi by 2, two terms, 1 by 2 cos square x by 2 plus sin x by 2 cos square x by 2. I split into two terms. Again you know this is equal to integral 0 to pi by 2. This is 1 by 2 into 1 by cos square x by 2. I can write it as secant square x by 2. 1 by cos square is by trigonometry, it is secant square x by 2 plus again in the numerator sin x by trigonometry result half angle formula. Sin x is 2 sin x by 2 cos x by 2 by already 2 cos square x by 2 in the denominator into dx. E power x you have e power x the integral e power x into 1 by 2 into 1 by cos square is secant square plus sin x I can replace by the trigonometry result half angle formula sin theta equal to 2 sin theta by 2 cos theta by 2 you know. Therefore the sin x and we express as 2 sin x by 2 cos x by 2 by already the 2 cos x by 2 as it is right. Now again this is equal to integral 0 to pi by 2 e power x into, I can cancel these two and 1 cos x by 2 by the square term is cancelled by 1 cos x by 2. Therefore, you get sin x by 2 by cos x by 2 is tan x by 2. The second term I am going to write as a first term. Sin x by 2 by cos x by 2 is tan x by 2. Because cos and cos square, one cos term is cancelled in numerator denominator and 2 cancel, sin x by 2 by cos x by 2 is tan x by 2. Okay? And the second term is 1 by 2 into secant square x by 2 into dx. I can rewriting this term, I can bring this term into the first term, sin x by 2 by cos x by 2 as tan x by 2. Already e power x is there, and 1 by 2 secant square x by 2 I can write it as the second term. So why I am writing like this is, here is when we are using one property, that is integral e power x into f of x plus f dash of x dx. It is one property. Integral e power x into f of x plus f dash of x dx is equal to e power x into f of x. That is your answer. If a function and its derivatives are adding and multiplied by e power x, integration of e power x into a function and its derivative gives you the e power x into that function only. So you can see e power x into tan x by 2 is f of x. Here f of x is tan x by 2. Therefore derivative of f of x, f dash of x is tan x by 2, derivative is secant square x by 2 into derivative of x by 2 is 1 by 2. So f dash of x is secant square x by 2 into x by 2 derivative 1 by 2. 1 by 2 secant square x by 2 is f dash of x. So it is of the form f of x is tan x by 2. F dash of x is, what is that? 1 by 2 secant square x by 2. So f of x is tan x by 2, f dash of x is 1 by 2 secant square x by 2. Therefore, it is of the form integral e power x f of x plus and its derivative is e power x into f of x only. Therefore, the answer for this expression is equal to e power x into f of x is tan x by 2. Limit 0 to pi by 2. That's all about answer. By using this property, your answer is just e power x into f of x. E power x into f of x from 0 to pi by 2. Apply the first upper limit. E power pi by 2, e power x plus is e power pi by 2 into tan x by 2. Pi by 2 by 2 is pi by 4. X is pi by 2. Pi by 2 by 2 is pi by 4 minus lower limit e power 0 tan 0. Tan x by 2 is tan 0. Okay. You know tan 0 is 0. Here you apply the result, lower limit. Applying upper limit is e power pi by 2 into tan pi by 4 into minus lower limit is e power 0. Applying 0, e power 0 into tan 0. Okay. This is e power pi by 2. What is it? Tan pi by 4 is 1. E power pi by 2. This is 1. E power 0 is 1. 1 into 0 is tan 0, 0, 0 into everything is 0. Therefore, second element is 0. Therefore, e power pi by 2 into 1 is e power pi by 2. Answer for this problem is e power pi by 2. So, the evaluation of this integral is e power pi by 2. Just your answer is e power pi by 2. This is e power pi by 2, tan pi by 4 is 1, 1 into e power pi by 2 is e power pi by 2 only because tan 0 is 0. Okay, using this property, this is the property. This is the property we are using. Okay, integral e power x into f of x plus f dash of x dx is e power x into f of x. Using that property, we are evaluating the problem. That's all. Next problem is using trigonometry results are also essential for solving this problem. Okay. Next problem. Evaluate the integral 0 to pi by 2 root of cos theta into sin cube theta d theta. This is the problem. Evaluate integral 0 to pi by 2 root of cos theta into sin cube theta d theta. Okay? Here I am going to rewrite this problem as 0 to pi by 2 root of cos theta, and this sin cube is I split into sin square theta into sin theta. I split this sin cube as sin square into sin into d theta. Cube is expressed as square into sin, that is sin cube. Now I am going to substitute t equal to cos theta. Here I am going to give a substitution for cos theta, t equal to cos theta. In this expression, you put t equal to cos theta. What is dt by d theta? Cos theta derivative minus sin theta into theta derivative is d theta. D theta by dt is minus sin theta. That d theta comes on the right hand side. So if t equal to cos theta, dt is cos theta derivative is minus sin theta into theta derivative is d theta. Minus sin theta d theta. And this minus sin theta d theta, I can write it as sin theta d theta by minus dt. I bring this minus to the left hand side because I want sin theta d theta here in the problem. Instead of that, I am going to replace minus dt. And sin square t, I can write it as 1 minus cos square theta. Again this problem, you see, and this problem integral 0 to pi by 2 root of cos theta into sin square theta is 1 minus cos square theta. You write it as cos sin square theta by 1 minus cos square theta by trigonometry. Sin square is 1 minus cos square into sin theta d theta. So in this problem, and the corresponding limits you have to change. If theta equal to 0, what is t? Because these are the limits of 0 and pi by 2 are the limits of theta. If you give a substitution in definite integral, if you give a substitution for a function in definite integral, the corresponding limits should have changed. See, if theta equal to 0, what is t? If theta equal to 0, t equal to cos 0. Cos 0 you know 1, so t equal to 1. Similarly, if theta equal to pi by 2, upper limit, if theta equal to pi by 2, t equal to cos pi by 2, cos 90 you know 0. Therefore, the integral of 0 to pi by 2 becomes 1 to 0. This lower limit becomes 1, upper limit becomes 0. Therefore, the problem becomes, you consider the problem is integral, instead of 0 to pi by 2, it becomes 1 to 0. Root of cos t is t because cos theta is t into 1 minus sin cos square t is t square because cos theta is t, 1 minus cos square is t square into sin theta d theta is minus dt. These are the substitution we have given. cos theta is replaced by t, therefore root t into 1 minus t square into sin theta d theta is minus dt. So if the again is equal to integral 1 to 0, you bring this minus out of the integral, you bring this root t into 1 is root t minus t square into root t dt. I am bringing this minus out of that integral. So this is equal to here one property. Integral, one property here of a different is here, one property is that minus integral a to 0 f of x dx is equal to, if you multiply by minus, the sign of the limits of the integral change 0 to a. A to 0 becomes 0 to a f of x dx. This is one property. Integral 0 to a f of x dx is minus integral a to 0 f of x dx. If you multiply the integral by minus, the limits are interchanged. Therefore, if you multiply by minus, in this integral become, instead of 1 to 0, it becomes 0 to 1. Because of this property, this integral becomes 1, instead of minus 1 to 0 is 0 to 1. Root t, I can write it as t power of minus t square into root t square into t power of, t square into t power of, t power 2 plus 1 by 2, that is 5 by 2. 2 plus 1 by 2, this is 5 by 2 dt. So this integral becomes integral 0 to 1 t power of minus t power 5 by 2 dt. Now you evaluate this integral as usual, you will get the answer. See here. Now first integral is on integration, t power of integral is t power 3 by 2 by 3 by 2 minus integral t power 5 by 2 integration t power 7 by 2 by 7 by 2. That's all from 0 to 1. See, by integrating this step, t power of is t power 3 by 2 by 3 by 2 minus t power 5 by 2 plus 1 by 5 by 2 plus 1 is t power 7 by 2 by 7 by 2. So that is equal to 2 by 3 into t power 3 by 2 minus 2 by 7 into t power 7 by 2 from 0 to 1. First apply upper limit. 2 by 3 into t power 1 power 3 by 2. T power 1 power 3 by 2 is 1. 1 power 3 by 2 minus 2 by 7 into t power t equal to 1 power 7 by 2 minus, for upper limit this is given, lower limit t is 0, 0 power is 0. So t 0 power 7 by 2 is 0, 0 and this thing is 0. So lower limit, both the cases 0 because 0 power 3 by 2 is 0. If you give t for 0, 0 power 3 by 2 is 0, 0 power 7 by 2 is equal to 0. Therefore, lower limits are vanished. You just get only the upper limit. So that's equal to 2 by 3 minus 2 by 7. That's all. 1 power 3 by 2 1, 1 into 2 by 1, 2 by 7. So LCM is 21. Yes, you can take 2 as common term, you will get 2 into 1 by 3 minus 1 by 7, simply you get 2 into 21 if you take 7 minus 3, that is equal to 4 3s are 4, 7 minus 3, 4 into 2 are 8 by 21. Okay, otherwise 7, 21, 7, 14 minus 6, 8 by 21. If you write it also, if you are not taking this LCM, you will just write it as 21 as LCM, 7 3s are 21, 7 2s are 14, minus 3 7s are 21, 3 2s are 6, 14 minus 6 is 8 by 21, whatever it will. That's our answer. That is the problem. So here we are using this problem. If you are in a different integral, the limits are interchanged if the integral is multiplied by negative sign. That's our problem next. Next problem I am going to solve one more problem. One more problem I am going to solve now. That is integral 0 to 1. Okay. Next problem. Evaluate these integrations are very, very important. Different integrals by using properties are very important. Next, evaluate the sum integral 0 to 1. Third one, integral 0 to 1. 1 minus x square by 1 plus x square whole square dx. Okay, here to evaluate this integration, you substitute x equal to tan t. X equal to tan t. By giving what is dx? Tan t differentiation is secant square t dt. So if x equal to tan t, dx is tan t derivative secant square t into t derivative of t is dt. Correspondingly, limit will stand if x equal to 0. If x equal to 0, tan t equal to 0. If x equal to 0, tan t equal to 0, so t equal to 0. Tan 0, 0. Similarly, if x equal to 1, tan t equal to 1. Tan t 1 implies t equal to pi by 4. Therefore, the limit 0 to 1 becomes 0 to pi by 4. Therefore, this integral becomes 0 to pi by 4. 1 minus x is tan t. So 1 minus tan square t by 1 plus tan square t whole square. Okay. So this is again equal to integral 0 to pi by 4, numerator 1 minus tan square t, you keep as it is, numerator, but denominator is 1 plus tan square t is secant square t. Is it not? Yes, 1 plus tan square t is 1 plus tan square t into whole square. I can read it again as 1 plus tan square t. I am splitting that integral into two terms dt. The whole square is split into two terms, 1 plus tan square t into 1 plus tan square t. Okay. Now this is becomes integral 0 to pi by 4, 1 minus tan square t by 1 plus tan square t into 1 by 1 plus tan square t dt. So this is equal to integral 0 to pi by 4. 1 minus tan square t by 1 plus tan square t is cos 2t. This is 1 by 1 minus tan square, 1 plus 1 by 1 plus tan square is secant square t dt. Okay. What is dt? Secant square t dt. And dx can be replaced by, see here dt is secant, dx is secant square dt. You are not supposed to write simply dt. It is secant square t dt because dx is secant square t dt. So you will get secant square t dt. In this here you have dx. Suppose that dx is replaced by, what is that? secant square t dt because dx is secant square t. So this problem, this step, is done. Integral 0 to pi by 4, 1 minus tan square t by 1 plus tan square t whole square into dx. Instead of dx, you get secant square t dt. So this is the problem. Next step, you will split the denominator into 2, and also you will get 1 minus secant square t dt. Here also you will get. Here also you will get secant square t dt. Right? Therefore, these two terms cancel. Simply you will get integral 0 to pi by 4 cos 2t 1 into dt is dt. That's all. Now it is simple. Integration of cos 2t, you know. Cos 2t is sin 2t by 2, 0 to pi by 4. Now apply the first upper limit, pi by 4 for t, that is sin 1 by 2 into sin t, pi by 4, pi t for pi by 4 you will get pi by 2, minus 1 by 2 into, if you put sin t for 0, you get sin 0. So this 1 by 2 is common, sin 2t, t for pi by 4, pi by 2 into pi by 4 is pi by 2. Therefore 1 by 2 into sin 90, 1, sin 0, 0. Therefore answer is only 1 by 2. That's all about the problem, sin 0, 0. Answer is 1 by 2 only. So the value of this integration is 1 by 2. That's all about the problem. I will stop here. We will continue the remaining problems in the next video. Thank you.